proportions are when you take two ratios and set them equal to each other. We can actually solve proportions, and the way that you prove a proportion is actually a true proportion is by using what's called the cross product. Cross product essentially means that you are going to take, say, the top of one part of your proportion and multiply it to the bottom of the other. And then your goal is to see if the two sides equal. So the best or the easiest thing for me to do is to just go ahead and show you the example. So we have 7 is to 3. That's what this this essentially means is to. So 7 is to 3, and 21, again we have it, is to 9. So the way that we set this up is 7 over 3. The and means equal, and then we have 21 over 9. So what the cross product says is I'm going to take the top of one side and the bottom of the other, and then vice versa, the top of the other side, bottom of the other. So what we're going to do is we are going to multiply. So we're essentially going to do 7 times 9, and we're looking to see if that's going to be the same as 3 times 21. So we know 7 times 9 gives you 63, and 3 times 21 gives you 63. Since this is a true statement, what that means is that the pairs are proportional. Okay. Some people think it's just as simple to write, say, the word true or the word yes. So it's personal preference how you want to identify it, but this is the math that you have to do. We're doing what's called the cross product. So let's take a look at this one. Notice it's fractions. So before we even get to the cross product, one thing you want to do is you want to go ahead and take a look at them. So here we're going to have 5 and 1/3 is to 8 and 1/4. So in doing that, one thing that I would do is I would change these over to improper fractions. So when we're looking at this, we have 5 and 1/3. So that is going to give us the bottom times the big number plus the top all over the bottom, and then same for this bottom fraction. We're going to have the bottom times the big number plus the top all over the bottom. So let's go ahead and reduce that. So we have 3 times 5 is 15 plus 1 is 16. So this is 16 over 3. And then 8 times 4 is 32 plus 1 gives you 33 over 4. And then you need to remember your fraction rules. So our fraction rules say first you're going to keep the top, then we're going to change to multiply, and last we need to flip the reciprocal of the bottom. And that's how you're going to rewrite it. So here this is going to give us 16 over 3, so keep the top, change to multiplication, flip the reciprocal, becomes 4 over 33. If we multiply straight across, we end up getting 64 over 99. So that is actually this first fraction here. reduced down. We also need to do the other. So we have 2 1/5 over 9 1/2. So 2 1/5, again, this is going to be the bottom times the big number plus 1 all over the bottom. And do it again. The bottom times that big number plus 1. Now we need to reduce. 5 times 10, or 5 times 2 is 10 plus 1, gives you 11 over 5. And do the same to the bottom, and you end up with 19 over 2. Again, we're going to keep it and change it, so this becomes 11 over 5, change the multiplication, and then 2 over 19, which this then becomes, through multiplication, 22 over 95. So if we look, we have my 5 1/3, 8 1/4. Well, we reduce that to 64 over 99. And then that should equal the other side, which we reduced to 22 over 95. Now we can go ahead and set up, and we can do our cross multiplication. And so here, this is going to give us 64 times my 95, and does that equal the 99 times 22? Well, 64 times 95 is 6,080. 99 times 22 is going to be 2175. If you look at both of these are not equal. Since this gives us a false statement, that means that it is not proportional. Now that is just one such way that you could approach the fractions. Okay. The other thing that we could have done to approach the fractions is, when we got down to having 5 1/3 over 8 1/4 reduced to 16 over 3 over 33 over 4, stopping there. We then also had our 2 1/5 over 9 1/2, which we reduced down to 11 over 5 and 19 over 2. So we could have stopped at this point instead of reducing both of these fractions down, and we could have set our proportion up for there. Setting it up would have said we had 16 1/3 over 20 over 33 over 4, and this is supposed to be equal to my 11 over 5 and 19 over 2, and done our cross multiplication here. So notice these two fractions would have been multiplied, and these two fractions would have been multiplied. So if we had done it that way, then we would have been set up with 16 over 3, and we're multiplying that by 19 over 2, and we're checking to see if that equals 33 over 4 times 11 over 5. So on each of these you would multiply, so we would go straight across the top, 16 times 19, which gives you 304 over 6. And then on the other side we have 11 times 33, which gives you 363 over 20. And then what you do is you would look to see if these can reduce down to the same fraction. So we have 3 over 4, 304 and 6. So one thing I know that can come out of both of these is an even number. I can divide a 2 out. When I'm looking at 304 divided by 2 gives me 152 over 3. On the other side, if you look, I have 363 and 20. So the first thing that I might look at is if I have 363, can I divide, say, a 4 out? Or basically, can I divide anything out that would come out of 20? And that answer is no, so this stays as 363 over 20. As you can see, these fractions are not equal. Therefore, we have the same not proportional. Okay, so this would be looking at it in fraction form. The other thing that you could have done is simply looked at it in decimal form, doing 304 divided by 6, giving you the decimal 50.6 repeating, and then having your 363 divided by 20, which gives you 18.15, thus again showing you not proportional. So any of those different ways is a perfect way to be able to show either is or is not proportional, and you can use, again, the different methods. So depending on where you want to stop, it's completely up to you when dealing with fractions. Now, solving proportionals is going to be doing the exact same thing, only you can see we have a variable in one of our places. So let's go ahead and solve these proportions here. So first, to do so, again, we're going to use the cross product. So this is going to end up being 8 times x is equal to 12 times 20. So when we do it, we have 12 times 20, which is going to give us 240. So I have that 8x equals 240. I need to get x by itself, so I'm going to divide everything by 8, and we end up with x being 30. So that is solving. So this is the answer we wanted. Again, let's do it again. Here is my variable. So in this case, I'm going to have 11x is equal to 8 times 5. This means 11x equals 40. So x is 40 over 11. And this is the answer that we were looking for. We can do it with decimals. So here you're going to have 2x is equal to 11 times 7.1. So this means that my 2x is going to be equal to 78.1. Divide everything by 2, and x is going to be 39.05. And this is the answer I wanted. We can also do it with fractions. So here, when we look at our fraction, the first thing that we do is we need to set it up. So here we're going to have that 7x is equal to 1 times 4.5. I would change my fraction to an improper. So this one right here, I would do what's called your mixed to improper. So here I've got my 7x is equal to 1 times anything is itself, so this is going to be bottom times the big number plus 1. So bottom times the big number plus 1 all over the bottom. So 4 times 2 is 8 plus 1 is 9. So this is 7x is equal to 9 over 2. So here, one thing that we can do is we know that we have to divide the whole thing, but most of us don't like fractions. So the easiest thing to do, which does add an extra step into your problem, is you could multiply this whole thing by 2, which changes this to be that 14x equals 9, so x equals 9 over 14. Or you could have taken what you had, so the 7x equals 9 halves, and simply divided everything by 7. Using the fraction rules, this would give you x equals 9 halves times 1 over 7, so x equals 9 over 14. Either way that you chose to do it, you still get the answer you needed, which is that x is 9 over 14. Okay? So whether you multiplied it first and then divided, or just simply divided but had to use your fraction rules, gives you the same result. Now let's do a couple more here that are a little bit more slightly complicated. So if we take a look at this first one, notice we kind of have to figure out what is what. Here is the biggest advice I can give you. If you notice that these two lines are sitting at about the same place, then this means that 6 is a whole number and 5/4 is a fraction. So what you do is you kind of want to look at where the proportion line is sitting. They will be sitting in the same place on either side. So to solve this one, we're going to have 5/4 times y is equal to 6 times 8. So I have 5/4 times y is going to give me 48. I need to multiply everything by 4, so I get that 5y is equal to 192. Then I need to divide everything by 5, so I get that y is equal to 192 over 5, and this is my proportional answer. Last, this one. Again, we've got a 4 on top and we have the fraction on the bottom. So here this is going to give you 4y is equal to 15 times 4 2/3. So this 4 2/3 I would change to improper. So my 4y is going to equal 15 times, and then one more time it's going to be bottom times the big number plus the top, and the bottom stays the same. So my 4y is equal to that 15 times 3 times 4 is 12 plus 2 is 14 so 14 over 3. Now one of the things you could notice is that 15 and 3 can reduce. This becomes a 5 and this becomes a 1. So I have 4y is equal to 5 times 14. So my 4y is equal to 70. Therefore, I need to divide everything by 4. So I get that y is equal to 70 over 4. However, this can reduce. So y is actually going to be 35 over 2, and this is the proportion. So a couple things that you need to remember. when dealing with proportions is, one, you want to reduce everywhere. The second thing that you want to remember is you always want to do mixed to improper, because that's going to help you along the way with your reductions. Okay? And then the third thing is you can always check your work by using what I call the plug and chug. What that means is you take the answer you get, plug it in for where y is, and then you retest to make sure your proportions equal each other. So in a nutshell, that is everything that you need to know about the beginnings of being able to solve for proportions. So if you have any questions, please let me know. Otherwise, have some fun, relax, be creative, and I'll see you next time.